Yeah, somebody was telling us where we were. So please continue, please.
You were explaining to us how to make use of the DOE
Okay.
when we have in a factorial form where you told us to go on start, DOE, factorial, create factorial design, number of factors. Then from there, we start seeing boxes where we select our design, whether full or the other one. So you say we should choose full. Number of centers, blocks, you say we should take tray. Then from the box that was produced, where we have factors, name, type, you were telling us what to do like that before the thing went off.
Okay. Thank you very much. That's a very good one. That's a very good one. So I think we should go back to that place. So this material, please, the organizer will give us this material so you can use it to read more. But I think we should go back to our practical. So we saw how we actually generated this table. Now on this Minitab, let me clarify something for you. Whether you're using Minitab, Design Expert, or any software, these ones will definitely come. Okay. This standard order, run order, center points, blocks, they've definitely appear. Okay. They are the statistical coding that they are using to help follow your data. Okay. So for your experiments, your what have you, you don't need them. Do you get? You don't need them. So let's say that you have done generating data now. These are what you need from here, just like this. Just copy. Hmm? Copy up to here. This four. Copy it. Copy it. Can you see? You copy it. I've done Control C now. Copy. Or right click. Control C is fine. So I've copied. Then you can paste them. Okay. You can paste them here. You can paste them here in your own this thing. So can you see? So this is what I have based on the data that the full factorial generated for me. Okay. So let me shorten this. I'll just shorten it to stash. Stash. Can you see? Stash. Yeah, this one is what? Water. H2O. Okay. This one is, are we following? Are you seeing my screen? Okay.
Yes, sir.
This one is glycerol. And this one is what? Vinegar. Vinegar. Okay. So this is the data that it generated for me. Okay. So it's very simple. You can save it. Save it. By the time you do your own, you can save it. Then you now come to some people want to paste this data on Excel. If you paste it on Excel, you might have more visualization. Let's do Excel. Please, I want you to be doing it if you have your system there, because once we go now, there's no break to return. All right. So if you come here, you can paste it here. Can you see? So when you paste it here, you now say you can call it table, I don't know. In that our work is table what? Table 2. Table table 2.0. Okay. Full factorial, full factorial design.
We can't see what you are doing, sir.
Okay, okay, okay. My Excel. I'm not showing my Excel. Thank you, sir. So I brought Excel, then I pasted the data. Can you see my screen now?
Yes,
Yes,
sir.
sir.
So I pasted that same data to this Excel. This is it. Okay. So see it again here. Can you see it? I just pasted it from where I copied it from here. You know, we copied it that time from here. We came down like this, and we pressed Control what? Control C, and then we pasted it here. This is it. So after pasting it, I now said we can call it full factorial design of experiments. What's your experiment for maybe, I don't know, let's say bioplastic production or plastic synthesis. Yes, synthesis. So this way, you are giving the unique name. It's no more generic. Then here, you can then come here to do like this. You can do like this. You can create borderline. You have formed a table. And this table is from Minitab. So these are the experiments that you now want to run. You can create, maybe you can write runs here. And then you have 1 is equal to, you go up plus 1. Then you have 2. Then you go down like that. All right. So you can, so with this now, you have a full table and your experiment, after performing your experiment, maybe you now generate what? What did we generate? Let's say you generated what? Energy. You know, I'm an engineer, so we are always concerned about energy. Okay. You are concerned about yield. Yield. And also about mass. Okay. So these three things are things that you are concerned about. So when you are doing the experiment, you are checking the energy. Maybe the energy here is 350. Maybe the energy here is 300. You get after doing the experiment. Maybe the yield here is 90%. 90%. The yield there is maybe 85%. Like that, you feel it. So I now said you can fill in that data from here. So I brought some data from here. I brought some data from here. Very good. So I now said, let's fill in this data from here. Up to 19. So I took only 19. Okay. And I pasted it here. Okay. So I was saying let's focus on mass instead of yield. Let's focus on mass because I don't have yield in my data. Okay. So then the mass up to 19. Okay. So also pasted it here. So this same pasting is what I did on Minitab. Minitab is that an Excel extension. Can we see it? So this same pasting, you can see it, is what I did here. Okay. And here. So if I want to paste this one now, let me copy it. Okay, now I just noticed something now. See this data. It has overflow because I did not start from hop. Can you see? So you can clean it. Can you see that? So you just cut cell. So everything will shift up. So that's part of cleaning the data. Can you see that? Can you see that it's now balanced 1919? So with this now, I can then now analyze this. Once I have this data here, this is data from this experiment data generated. These are the experimental runs. This is the result, response. Okay. So I then now come here to start DOE factorial. Since I'm doing factorial, don't forget, tomorrow we are doing response, but today factorial. So we now come to analyze what? Factorial. Can we see that again? So let's say it. Let's say it. Start. I need one person to say it. Start. DOE.
That's
DOE.
DOE.
Factorial. Then analyze what? Factorial.
Factorial this.
Exactly. Or what do you want to do? After you have already generated your factorial and you have already gone to your lab to get all this data, that's your responses. What else you want to do? You want to analyze your data. Do you get that? You want to analyze your data.
Yes.
So this is the experimental, this thing, the thing that, okay, to design it, go and run this experiment, go and run this experiment. You've run it one by one. After running it, these are the things you got, energy and what's called mass. Let's say you get you, so you now want to analyze it. So you now come to start, DOE, factorial, and what? Analyze factorial design. You can see that. Okay, good. So I'm going to drop that in your group immediately we finish this experiment. So, but please let's follow. So I'll go again. Start. Somebody else. DOE. Factorial.
Factorial. Analyze factorial
Very
design.
good. So you now pick it. I want to pick energy now. You pick energy. You select. Then you pick mass of this thing also.
You select.
You select. That's you're doing it one by one. But if you want to do at a time, let's say you have so much here to do, you don't need to be doing one by one. Just click on one, press shift down, then you tap everything. Pam, 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 pam. Can you see? Everything. Then you
Yes.
press select. You will move to this place. Everything will move there. All the ones you want to analyze will move there. Then when you are after that, you can check terms. These terms just to see, okay, did I set it properly? Yes, you can see 4. All you are doing is 4 factors. Then I set it properly. A, B, C, D is there. Mass of starch, volume of this, volume of this, volume of that. Do you get? Everything is there. So you can just check. That's just for you to check. Okay, then you said okay. Then you also check properly that it's including what? The center points. You must include it. Okay. Then you now come to option. Okay. So for this option, look at the thing that matters here. Confidence level. 95% confidence level. Except if you want to do your own research at 99% confidence level, you change to 99%. But the overall, but the general default confidence level is what? 95%. Then two side, you leave two side. Okay. Then you okay it. Then you now come to where stepwise. That one you leave it. Then you come to graph. Okay. For graph, you want to have individual plots. But that individual plot, what are the things you want to show there? I want to show histogram in the individual plot, normal plot, residual what versus fits, the residual versus what versus order. You get, you want to see that. Then you say okay. Then in the results, you want to have all these things: method, variance, model, summary, coefficients. Do you get that? All of these, you want to see all of it in your results. Because if you could have done this yourself, but it will take time. You'll be pressing calculator, getting the table, then calculating the information. It will take time. It will take time. You can do it. Everybody can do it. We all pass mathematics in O level, and we all do statistics. But it will take time. So instead of you to be doing it yourself, that's why you're selecting all of this to be done for you. Then you now come to this table, and so you want expanded what? Table. With the expanded table, you can have more data. You understand? So you say interactions up through order. but I wanted it to be default. So I leave that default. All right. So as much as you are getting more dexterous with these statistical tools, or you have a preference for order of interaction, you can then select the order of interaction and you can decide to say 1, 2, 3, 4. Okay. So, but here, I just want it to be a default. Default means that let it be the way it is inbuilt in Minitab. If it is A to A, B to B, C to C, or like that, A square, B square, let it be like that. Let me see it. And let me now use my p-value to select the one that are significant for me. Exactly. Exactly. So now we click OK. So then storage. So how do you want your factorial design to be stored? You want fits? Do you want residual? You want standard residual? You pick everything you want. If you don't want effects, leave it out. But if you want it, you pick it. Coefficient, design matrix. All of these are helping you to see the accuracy of your data. So the fitness will help you see a lot of data. Residual will help you to see how the residue looks like. Then the standardized one, the deleted residuals, your leverage, your effects, and then the coefficient, then design matrix. So they're helping you to see how accurate your data is and their interaction. So when you pick it, you click OK, and after that, you are done. So what makes you say you are done is to now click the final OK. With this final OK now, you'll be able to see all of your attributes in this very, very, what is it called? Research. So are we good to go now? So now I'm going to click OK. Then you will see Minitab magic doing it for you. So I'll click OK. Can you see now? So Minitab now extended to what? C11, C12, C13, like that. Calculating so many things for me. These are fitness 1, fitness 2. Fitness 1 is for energy. This fitness 2 is for mass of. So that's how it is. RS1 is for energy. RS2 is for. Do you get like that? So because I only selected 2 response, so it's giving me 2, 2, 2, 2, 2, 2. Now I selected 4 response, it's telling me 4, 4, 4, 4, 4, 4, 4. So now look at the table. These are the tables of the regression. Okay. So these are my p-value. So for p-value, you check this p-value, is it less than 0.05? For the first one here now, it's less than 0.05. That means this constant is correct, is valid. This one now is more than 0.05. So this very value now is not useful, like it's insignificant. This one too now is more. So any number that is more than 0.05, you will not pick it. Do you get? You will not pick it. You will collect this table, you will paste it, but you will not pick this value to make your description. So the value that you will pick is just here now. This is just this constant that is correct here. Mind you, this very data is actually generated using what's it called now? Buzzbucket. But I'm only teaching full factorial as the first point, as a first appreciation of Minitab. So you can see how it is. So I'll give an assignment, and by tomorrow we'll now come and use Buzzbucket and see a better approximation. Is that fine? Is that fine? So look at this R now. This R now. This R square is very close to what? It's very close to 100%. So that's to tell you that the model is kind of reasonable. But look at this adjusted R. Adjusted R is very low. So that means there are some factors there that are ignored, like those ones that are not up to what? That their P is more than 0.05, their P value. So these are the ways to interpret all of this. So please, I want us to practice this now in this class. Oh yeah, those that have their laptops, oh yeah, practice it now and share your screen and show me what you have. Then from there, we'll decide if you are closing or I introduce you to Buzzbucket and give you assignment and we'll close. Oh yeah, those that have their laptop, oh yeah, practice yours. Let me see what you have.
That's school run, no.
You said school runs.
School run, no.
Okay, I see. Okay, so I'll give you an assignment. I hope it's clear, Sha. It's clear the way I did it.
Yes, sir.
Okay, good. So I'll give us an assignment now. Your assignment is
Yeah. We would like to have the recorded video.
I will send it. I will send it. Just know that there's so much noise in some of them. I'll send it. So look at the assignment. So this is the assignment on the screen. So you run ANOVA for the DOE. So you go to DOE factorial analyze. So you run ANOVA. Then you check the outputs for the P, the F, just the way I did it. Then you generate the main effect, the interaction. Okay, it's very easy. It's very easy. It's very easy. Let me show you again. Let me show you again. So these are all the things I was asking for. See the ANOVA table here. See the table. See the table now. See the analysis of variance. That's ANOVA now. That's modem summary. Do you get? So, but if you want to see them more, you can still do this. You can still do stats, DOE, factorial. Yes, you can come here and do factorial plots. And I can't talk to you. I'm busy. So you can do. So basically, all I need is already here for you to see, but I don't want to overload us with so much. Okay, so just do everything I asked to do here. Yes, and then you can copy it and put all of them in your words. Just this how to copy. Just normal copy now. Just right click. Then you can see you can send to Word from here. You will see them in Word document straight up. Can you see? Just come here, right click. Then you see send to Word. So whatever you want to copy, say you go to Word directly. I'm going to show you now how to do that. So like mine now, that's already sent to Word. Okay. And then I can get it from here. Can you see it here? Can you see the Minitab training is still, do you see that? So
it's not showing.
Okay. Yeah, it's already copied into my Word. So you just go and check your documents to fetch it. So I will share the screen now. Let me share the screen. So this is send to Word. So once you click send to Word, okay, you go to your documents where your Minitab is installed. You will see the document there. That's one way. Another way is that you can copy it directly and paste it on what? On Excel. And paste it on Excel. So is that fine? So let's call it a day. Thank you all. Is there any questions?
Yes, sir. Yeah, please, what is the significance of the Excel that you opened?
I just used to show you how to copy the generated, look at it, how to copy the generated runs from Minitab. When you copy it and place here, you can then copy it and add it to your research. You know, this is for research or policy. So when I copied that time, I copied on Word directly. Word we did not arrange it properly. There was no line, there was nothing. Look at it, look at the way it appeared. Can you see? See the way it appeared? This way. And I'm not comfortable, I'm not okay with it. Look at the way it appeared. I had to even shorten this to make it look like this. Do you remember that? So, but if you paste it in Excel straight, if you paste in Excel straight, you will be able to have it in columns, and then you can draw your lines where I drew it, and then add it and make it full. Just like the paper I published here. Look at the paper I published here. Can you see this paper? This paper, I copied my stuff into Excel, and then I did this. Then later, and then was able to copy it and paste it back to Word properly. Can you see it? Can you see this data? I copy it to Excel first, do my cleaning, then come and paste it in Word. If not, Word, it will be difficult to do this type of magic in Word, this very thing in Word. This type of arrangement, it will be difficult to do it in Word. So I paste it in Excel first. Is that clear? Any other question?
Yes, sir. Sir, I want to know, you said something about generic data. What do you mean by that?
Okay, very good. When you did this, when you generated this very thing that time, when you generated this in that time, what you got from this design of experiment is generic data. These ones, they are generic data that you generated. Hmm? You generated them from what? From Minitab, using your upper and lower range. You know, we use 2D design. 2D design is lower and upper, lower and upper. If it was 3D, it would be lower, medium, upper, lower, medium, upper. So all this data that you fed in gave you this generic data. It's also called design data. Okay, this design data. So you now went to lab to go and use this design data to get responses. These are your own results, your lab results. This lab result is energy. This is mass. You use your weighing balance to measure this. You use your energy meter to measure this. If you are using a FTRL, maybe you measure some other things. So for each sample, so this one is not generic. This is generic. So now another way I use the word generic is when I was telling you about this table. I said if you want to type this table, you can call it table 2.0 full factorial design of experiment. I said this word is generic, but when you add what you are doing with it, it's no more generic. So generic just means that that word or that thing is from a particular place that any other person can get it from there. And this very word now, full factorial design of experiment, everybody knows it, everybody can say it, so it's generic. Those are your data that you generate also from the system. Okay, we can also call it generic because if any other person goes there to generate it, to put it, they will get it out. All right. So for you to make it unique to yours, you now had for whatever you are synthesizing. I'm synthesizing bioplastic. Maybe you are synthesizing a drug or a vaccine, or you are looking at cutting costs. You just put your specific your own specific, you tailored it to your own experiment here by adding this. Is that clear, sir? All right. So in the absence of no question, please, tomorrow class is by 4 o'clock, or should we move it to 2 as well? Just that I have,
Yes, sir.
I think we should move it to 3.
I have current,
to 2 or even 1.
I have current is they are coming to my office tomorrow, and I am one of the people that should be on ground. So I don't know. Let me check the timing again.
That too would have been more better.